All right, this is lesson 412, scale drawing. How do we use a scale drawing in order um, to draw a scale model? So scale drawing is kind of the same thing as a scale model. It's two-dimensional, and it's kind of like when we use a map. When you use a map, the map is usually the same exact shape of the land that it's measuring out. So that is those would be considered similar figures, like what we learned yesterday. So how can we determine the distance between 2 points if we're given a map? So on a scale drawing, which is a map, you have what's called a scale, where you have sort of measurements like this, where it tells you what actual measurement, which is 5 miles, is equal to the map measurements, which would be inches. If you were to look at a map of Pennsylvania, which is 250 miles by 450 miles wide, it wouldn't make sense to have a map that big. So that's the purpose of having maps. So Eulalia uses a map of Pennsylvania to determine that Valley Forge is 14 miles from downtown Philadelphia. Did she really measure 14 miles? And the answer would be no, because 14 miles would be big for a map. So if we look at the scale here, 14 miles, that's almost three of these. So that means on the map, it would almost be three of those, right? So 14 miles would be almost 3 inches. And then we can find the actual measurements by using certain math properties. Okay, so here is a drawing of a street view for the first question. Has to do with Guillermo. He needs a scale drawing of his house placed on a suburban lot. The lot is 56 feet wide by 100 feet deep. The garage is 20 feet back from the street, and he has a sketch of the house not drawn to scale with the measurements shown at the right. So what that means, not drawn to scale, is this shape of the house is not actually what it's supposed to look like, because it's not a very good drawing. If you look at the numbers, some of those numbers don't really make sense, right? So what we're going to do is we're going to use this information to draw what Guillermo's house is actually supposed to look like. All right, so we're going to use the graph paper to check out this lot. So we know that it is 56 by 100. So if we're looking at our graph paper, okay, which one of these is 56 and which one of these is 100? So it's kind of obvious this long one is 100, and then this one would be 56 feet. All right, so 56 feet, and this is 100 feet in actual distance. And on the map, so how many squares would equal a foot in this case? So if you want to count, there are 28 squares going this way, and there are 50 squares going that way. So what would that scale be? That scale would be that one of these squares would be 2 feet by 2 feet, right? Because if each one of these is 2 feet, 28 of them would be 56 feet. So this is the scale that we're going to use. So 1 unit equals 2 feet. All right, so here's our scale. 1 unit is 2 feet. And the way that it would be on a map is 1 unit, 2 feet. Okay, so those are equivalent. So let's keep that in mind when we're doing it. So the information told us on this map, on this page, is that the garage is 20 feet back from the street. So here's the street at the bottom. And if you look at your map right here, there's the street. So if it's 20 feet from the street, then how many squares would that be? Well, if we look at our scale, 20 feet, if 2 feet is a unit, that would be 10 units from the street. So we need to count up 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here's how far the house is where the garage is. So we're not going to actually draw the garage yet, because we don't really know where the garage is placed or where the house is placed on this lot. Okay, so can we find any other information that might tell us where the garage is? All it says is here's the sketch, and it's not drawn to scale. Okay, so let's look at the numbers here. And you see that number right there tells us that the house itself is 8 feet from the right edge of the lot. So whether there's a fence there or whatever, we don't know, but we know that it's 8 feet from here. So 8 feet would be how many units? So 8 feet is 4 units. So we know that this is 4 units. 1, 2, 3, 4 from the right side of the lot. So what this tells us is the corner of the garage is right there. That's the corner of the garage. And now where do we put all the other all the other lengths? Well, we know that, well, let's put this distance here. This is 20 feet. And this is 8 feet from here to here. This is 20 feet. Okay, so we can use the other measurements of the house that are given in this badly drawn drawing to draw the rest of it. So this front part of the garage that's facing the street is 15 feet. So if it's 15 feet, what would that be in according to our scale? So let me put the scale down here so we can also see it. So 1 unit is 2 feet. Okay, so 15 feet each unit is 2 feet. So that means it would be 2, 4, 6, 8, 10, 12, 14. All right, so here's 14. So how would we measure 15? We would just go another half of a unit, and that would be 1 foot. Half a unit is 1 foot. We're using equivalent fractions here, right? So we have 1, 2, 3, 4, 5, 6, 7, and a half, which if you notice now, there's a pattern. So 7.5 is half of 15. 4 squares, that's half of 8. So we can use this pattern for the rest. So what did it say about the side part of the garage? The side part of the garage is 17 feet from the back. So that's 17 feet. How many units would that be? So if we're using the same pattern, 17, we divide that in half, and we get, 17 feet. We cut that in half, and we get 8.5. All right, so that would be, remember, we're at 7.5 from the 15 feet. So that's 2, 4, 6, 8, 10, 12, 14, 16. And then if we go 1 more unit, that would be 18 feet, but we only want to go 17 feet, so we'll go halfway. So this is 17 feet. All right, and then on our on this side of also facing the street, they don't have a measurement here. So what are we going to put there? Well, if you notice, the opposite side of the house is 30 feet. The garage is 15. So that would make this side, that would make it 15 as well, because 15 and 15 is 30. So since this 15, if you remember, was 7.5 units, so this is also going to be 7.5 units. So this is already halfway. So that's 1, 2, 3, 4, 5, 6, 7 and a half. Okay, so this is 15 feet. And then we're going to look at the left side of the house. And the left side of the house is 38. All right, so how many units would that be? So 38 feet, you divide it by 2 to get the number of units, and that would be 19, 38 feet. So we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38. So we're going halfway. Okay, so that would be 19 squares. So if we're starting halfway, we're going to end up halfway. And then we're going to go 30 feet. So 30, that would be 15 squares. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There's our back part of the house. And then this side right here on the right. Okay, so this was 38 feet. This is 30 feet, and then the side would obviously connect all the way there, which is, it should be, since it's 55 feet, how many squares should that be? So we take half of 55, and that would be 22 and a half. Oh, I'm sorry, 27 and a half squares. So this is 27 and a half squares, trust me. And there you go. So this is the actual shape of the house. So if you see the actual shape of the house compared to Guillermo's drawing, you can see why I said it was a pretty bad drawing, because these are definitely not the same shape. All right. So this is what it should have looked like right here, and this is what it does look like. So the last part of it says Guillermo wants to put a rectangular swimming pool in his backyard. What is the largest pool that you would advise to have him installed? So we're going to look at some regulations to see what would be the largest pool that he can legally build.